Hey guys, this is going to be a video going over the Unit 7 test review. So in these first two questions, you're just determining whether the ordered pair is a solution to the system. Remember, a solution is going to be something that satisfies both equations, which is why the two lines would intersect on a graph. It's the point where the two lines would cross, and so what you'd want to do is just plug in both the x and the y into both equations and see if it works. So on the first one, plugging in 1, plugging in -4, and seeing does that equal -3. Yes, 1 plus -4 does equal -3. Okay, and then we have 1 minus -4, which is equal to 5. Okay, so it works for both of them. That means it is a solution. Do the same thing on number 2. If it doesn't work for either one of the equations at all, then it is not a solution. Solve the system of equations by substitution. So using substitution, we always want to solve for one of the variables in one of the equations first. Isolate one of the variables. It's always easiest to isolate the one that doesn't have a coefficient, if there is one that doesn't have a coefficient, if the coefficient is 1. So I would choose to solve for x in the second equation, so I'm going to add the 5y to the other side. That gives me x equals 5y. Now that I have that, I'm going to substitute 5y in for x in the first equation. Since I know x equals 5y, I can just replace that x with 5y. So I'm going to have -5 times 5y plus 3y equals -22. Now simplify this, we can solve for y. -25y plus 3y equals -22. -22y equals -22. Y equals 1. Alright, so I know y equals 1, which means I can cross off that one and that one, right? And now I'll just plug that back in to figure out what x equals. So I'm going to take that value, I'm going to plug it in for y right here. And so x equals 5 times 1, x equals 5. All right, you're using substitution on number 4 as well, but notice on this one they already have the y's isolated in both equations. So to solve this one, you just want to set the equations equal to each other. It's like you're substituting this in for that. Since y equals 1/3 x plus 4, you can replace that y with 1/3 x plus 4. So here's what it would look like. And then you're just going to solve for x. So I will let y'all do that, and you'll plug that x back in to get your y. Number 5. Okay, so we want to isolate one of the variables in one of the equations for substitution. You can do this either by solving for the y here, or dividing this equation by 2 to isolate the y there. I'm just going to divide that equation by 2. Divide everything by 2, and I'll have y by itself. So y equals 4 minus 5x. I'm going to replace that y in the first equation with 4 minus 5x. So I have 5x plus 4 minus 5x equals 4. Combine like terms. 5x minus 5x cancels, and I have 4 equals 4. We know that if you are solving an equation and your variables all disappear, they are eliminated, and you're left with two numbers that are in fact equal to each other, like 0 equals 0, or in this case 4 equals 4, then you have infinitely many solutions. So all real numbers are solutions. Now I'm going to change this to where it says infinitely many solutions, just because we didn't talk about it like this in the notes. But all this is saying is that anything that satisfies that equation is a solution. So this means the same thing as having infinitely many solution. So I'll go back and change that for you guys, both on the review and the test. It should say infinitely many solutions. For number 6, we're moving on to the elimination method. And so for this one, this is where you want to get 2 of your coefficients. So choose a variable, x or y. You want the coefficients to have the same number, but opposite signs. Okay, so I would on this one choose, you can decide for yourself what you want to do, but I would multiply this second equation by -2, and that will give my x's the same number. They'll both have a coefficient of 4, but they will have opposite signs, and that's what you want first. So distribute that -2 all the way across the equation. All the way across. So I have -4x plus 8y equals 0. Now what that allows you to do is I'm going to add these 2 equations together, and my x's are actually going to eliminate because 4 minus 4 is 0. Then I have 6 plus 8 gives me 14y equals -42. Divide by 14. Y equals -3. So I can already see that my solution is B. Now I'm going to plug that y back in just to make sure that x should be -6. So I should have, you can choose either of the equations. I'm going to choose the second one just because it looks a little easier. So 2x minus 4 times -3. So 2x plus 12. Subtract that 12, divide by 2, x equals -6. Looking at number 8, again, that answer choice should now say infinite solutions. So we want to multiply the first equation just by 2. If I just multiply that first equation by 2, then I can see my x's are going to cancel. So I have 8x minus 6y equals 16. Make sure you distribute that all the way across. Okay, and then -8x plus 6y equals -32. All right, now we want to cancel those x's. That's why we multiplied by 2. But notice you also have -6 plus 6 on your y's, which cancels as well. So you're left with 0 there. And then my 16 plus -32 is -16. Now, anytime you're solving equations and you're left with 2 numbers that are not equal, so your variables cancel, and you're left with 2 numbers that are in fact not the same, then you have no solution. And so that is going to be this guy, the 0 with the slash through it. No solution. And also mention that that means that these 2 lines are parallel. Right? There's no point where those 2 lines cross because they're parallel. All right, let's look at this word problem. Steve invests in a circus production. The cost includes an overhead of $117,000 plus production costs of $6,000 per performance. A sold-out performance brings in $15,000. Let X represent the total number of sold-out performances, X, number of sold-out performances, and write the cost function C and revenue function R. So cost is obviously how much he's spending on each show. We're adding up how much he's spending total. And then your revenue is how much he's bringing in total. So let's look at cost first. Cost is an overhead. Overhead means like the initial fee. So think he's renting this, he's having to pay for that, he's having to pay these people, whatever. The overhead is going to be $117,000. So that's his initial cost. Plus production costs of $6,000 per performance. So every time he does a show, another $6,000. So that would be times X, the number of performances he does. So 117,000 plus 6,000 per performance. And then revenue, how much he's making. He's making $15,000 per performance, assuming that it's sold out, which we are assuming. So that's 15,000 times X, and so that would be, let's see, looks like this one. All right, didn't ask us to solve, just set up the equations. Anne Mai owns a business making and selling jackets. She has a fixed cost of $1,320. So fixed cost, it costs $92 to produce each jacket. And the selling price is $104 per jacket. Determine the number of jackets that must be made and sold in order to break even. So when you're talking about breaking even, you're talking about cost equals revenue. You are making at least as much money as you are spending. That's breaking even. Okay, so first let's write our cost function. Cost is going to be 1,320 plus 92x. Selling price is $104 per jacket. So that's going to be revenue is 104 times the number of jackets sold. And we want to know when these two things are equal, so we are going to set them equal to each other. All right, solve for X. Subtract the 92 over. And divide by 12. 1, 1, 0. As the price of a product increases, the demand for that product decreases, right? Price increases, we don't really want to buy it anymore. However, at higher prices, suppliers are willing to produce greater quantities of the product. The weekly supply and demand models for a certain type of television are as follows. Demand equals the number they're willing to make, -4 times the price plus 780. Supply, the number, this would be the number they're willing to buy is equal to -4 times the price plus 780. Supply is the number they're willing to make equals 2.6 times the price, where P is the price in dollars per television. Find the price. So we're looking for P, the price at which supply and demand are equal. At this price, how many televisions can be supplied and sold each week? So we're looking for when the number of televisions demanded would equal the number supplied. So we will set these two equations equal to each other. -4P okay, I'm gonna add that 4P to the other side. And divide by 6.6. So price is going to be about $118.18. Okay, so either A or D for me here. And then the number of televisions would be, we can plug that back into either of those equations. So I'll just do N equals 2.6 times 118.18. There we go. You could plug that 118 back into either equation to get that, but all right. Through setting up the equations on number 12, but I'm going to leave those for you to solve on your own. It says 1 serving of ice cream and 2 servings of blueberry pie is 790 calories. 3 servings of ice cream and 2 servings of blueberry pie provide 1,290 calories. Find the caloric content of each item. So I'm just going to let's see, we're talking about ice cream. So I'm going to say x equals calories in 1 serving of ice cream. And I'm going to let y equals the calories in 1 serving of pie. Okay, so that means I've got 1 serving of ice cream, so x plus 2 servings of pie is 790. And then I have 3 servings of ice cream plus 2 servings of pie is 1,290. And then you're just solving for x. So you can use substitution or elimination. All right, getting into our equations with 3 variables and 3 equations. Our systems with 3 equations and 3 variables. On this one, we're just determining whether this ordered triple is a solution. So this is just like numbers 1 and 2, but now we have x, y, and z, and we have 3 equations to check. So you want to plug in x, y, and z into those 3 equations, make sure it works for all 3. So 2 plus 5 plus negative 3 needs to equal 4. Let's see, that's 7 minus 3 is in fact 4. 2 minus 5 plus 3 times negative 3. We want that to equal negative 2. So I've got 2 minus 5 is negative 3, minus 9 is not negative 2. So this one is not a solution. Easy peasy. Don't have to check the third one because it just already didn't work once. Has to work for all 3. Let's look at number 15. This is a system of 3 equations with 3 variables, but this is an easy kind where you have one equation that just has 1 variable, one with 2, and one with 3. So you're going to work your way up from that bottom equation up to the top. So first I will plug in negative 3 for z in the second equation, the one that has 2 variables. So 3y plus 2 times negative 3 equals negative 9. Okay, so negative 1. So far I have negative 3 for z, negative 1 for y, and I'm looking for x. So I will plug in both of those variables now into the first equation. X plus 3 times negative 1 plus 4 times negative 3 equals negative 13. Okay, so I got 2, negative 1, negative 3. Be careful when you're looking at those ordered pairs that you see they've got some of the numbers mixed around. It should be x, y, z. So make sure those variables are in the right order. All right, on this one, I know it's kind of funny, but on the first equation, you have all 3. On the third equation, you have all 3. On the middle equation, you don't have the y. You just have 3x plus z equals 2. So one thing you could do here is take the first and third equations and get rid of the y variable in that as well. So that then you will have 2 equations with 2 variables. So I'm going to take equation 1, name these 1, 2, and 3. I'm going to take 1 and 3 and I'm going to get rid of the y. So I'm going to do negative 3 times equation 1 plus equation 3. So that will be negative, I'm going to go ahead and multiply equation 1. Maybe I should just write it out like this. Negative 3 times equation 1. And then I'm going to just rewrite equation 3. And the reason I'm doing this is so I can get rid of the y variable in those equations, and then use that to solve for either x or z with equation 2. All right, so x, negative 3x plus 3y minus 9z equals negative 15. Okay, so now I'm going to add the two equations together. Oh, oops, I did not need to multiply by negative 3. I needed to keep those signs opposite, so that should still be a minus. So I'm multiplying just by positive 3 there. So 3 minus plus stays positive. All right, my bad. Okay, adding those two together now. 4x, those cancel, that's what we wanted. Okay, so now I have this equation. And what I can do is I can use equation 2 and this equation, I'll call it equation 4. And I can either use substitution or elimination to solve for x or and for z. I'm going to use substitution, so I'm going to take equation 2. I'm going to solve for z. So I know z equals negative 3x plus 2. Now I'm going to take that and I'm going to plug it in for z here. So I've got 4x plus 10 times negative 3x plus 2 equals 20. So that's negative 26. Zero divided by anything is 0. So x equals 0. And now I can plug that back in for x here to figure out what z is. So z equals negative 3 times 0 plus 2, which is 2. So by getting rid of y using equation 1 and 3, I was able to have a system of two equations with two variables so that I could solve for x and z. Now I can figure out what y is by using either equation 1 or equation 3 and plugging in the two numbers I now have, x and z. So I'm going to take equation 1 and I'm just going to plug in a 0 for x and a 2 for z to solve for y. Okay, got y equals 1. So I have 0, 1, 2. So my solution is 0, 1, 2. There you go. All right, 17. So on this one, you'll do something very similar where you will want to eliminate one of the variables in two different ways this time though. So I want to do this process here twice so that I will have a system of two equations with two variables. Okay, because this time I wasn't given an equation that only had two variables. So you can choose any of the equations you want. I would say, well, it really doesn't matter. I'm going to eliminate z. So I'm going to do equation 1 plus equation 3 first. And I don't need to multiply by anything because they already have the same coefficient of 1 with opposite signs. So I'm going to add equation 1 and equation 3. Okay, and look what happened there. So just coincidentally, my my y and my z canceled, which allows me to solve for x. Kind of convenient. Divide by 2. Didn't plan that. But I get x equals 1. So if you notice that 2 of the variables will cancel, so I've got -1, +1, +1, -1, then that's a good strategy. You can go ahead and solve for one of your variables. So I already know that either A or D is going to be my solution. All right, and now I can choose 2 of the another pair of equations. So this would be equation 2. So now I need to choose equation 2 with either of the other equations. So I'm going to do equation 1 and 2 this time. If I add those two together, my y is going to go away. So let's do that. Okay, so I add those two together, the y's cancel. I have 2x plus 2z equals -6. And since I already know what x is, I can actually plug this 1 in for x here, so 2 times 1. And I can solve for z. All right, so I know z should equal -4. But if you needed to figure out y, you would just take those two variables and plug them into any of the 3 equations. So I could do the first equation, 1 minus y plus -4 equals -7. That's -y minus 3 equals -7. Add the 3 over and divide by -1. So y should equal +4. I'll get you started on number 18, but I'm going to let you solve it on your own. It says find the values of a, b, and c such the graph of the quadratic equation passes through the points this, and this. Okay, so 3 points. So these are x and y's, right? These are all x's and y's. So you're going to plug those in for x and y in your standard form quadratic equation. So I'll have -25 equals a times -3 squared plus b times -3 plus c. Now use the second point, 5a, 2 squared, 2, and the third point. So plug in x for x and y for y all 3 times. Now I'm going to simplify that a little bit, actually squaring the numbers and whatnot. All right, so now what you have is a system of 3 equations with 3 variables. Instead of x, y, z, you have a, b, and c. So see if you can solve that system using substitution and elimination. As a tip, I do already notice that my b's have the same coefficient with opposite signs, so that might be a good place to start. Let's look at 19. The sum of 3 numbers is -6. Okay, so we are setting up some equations here. We have 3 numbers. As a hint, it says let x represent the first number, y is the second number, and z is the third number. So if it says the sum of 3 numbers is -6, I would just say x plus y plus z equals -6. The second number is subtracted from the sum of the first and third numbers. Okay, so it says if the second number, which is y, is subtracted from the sum of the first and third numbers, x plus z, The result is -4. So that is x plus z, and then y is going to be subtracted from that, and you get -4. If the third number is subtracted from the sum of the first and second numbers, the result is -2. So that's x plus y, and then z is going to be subtracted from that, and you get -2. Find the three numbers. So now we have three equations, three variables, and you can solve. I would first rearrange these. So the first equation is already in standard form, so I'm gonna rewrite that one. But I would rearrange the second and third equations. So that would be x minus y plus z equals -4. And x plus y minus z equals -2. All right, now you are ready to solve. Notice that you already have a lot of coefficients that are the same with opposite signs. I think these two would be a good place to start because you already have two variables that would eliminate immediately. The y and the z are going to cancel if you add those two equations, so maybe start there. All right, let's move on to the next page. A store sells tents, sleeping bags, and camp stools. So I'm going to say T equals tents, S equals sleeping bags, and C is going to be camp stools. A customer buys a tent, so one tent, 5 sleeping bags, and 2 camp stools, and it costs $231. The price of the tent is 7 times the cost of the camp stool. So the tent is 7 camp stools. The cost of the sleeping bag is 21 more than the camp stool. Find the cost of each item. All right, so you have, this one is actually pretty simple to solve. You have 3 equations with 3 variables, but notice these two are in terms of C. So what you can do is substitute this for T, substitute this for S, and solve for C. And then once you have C, you can easily get the cost of the tent and the and the sleeping bag by plugging that C back into these two equations. So I'll let y'all do that. All right, write the augmented matrix for the system of equations. So you know that the first 3 rows should be, columns. The first 3 columns should be your x's, your y's, and your z's. So 7, 7, 8, and then we draw that line. You know, it's not this one. It doesn't have the constants there. And equals 25. So 7, 7, 8, 25 should be your first row. 7, 7, 8, 25. Then 9, 3, 3, 15. Then 3, 3, -2, -11. Easy question. Should be an easy question to answer. Okay, this one has some variables missing, so you need to be a little careful. If you want, you could rewrite this 0y, 3z. Okay, so your first row should be 7, 0, 3, 39. 7, 0, 3, 39. It only has it on C. Then the second row, we don't have the x there, so that's 0x plus 5y plus 3z equals 2. So that second row should be 0, 5, 3, 2. 0, 5, 3, 2. And then the third row, 4, 3, 2, 25. 4, 3, 2, 25. You're just looking at those coefficients. They need to be in the order x, y, z equals constant. All right, and then you're going in the opposite direction here. So this should be your coefficients on your x, your coefficients on your y, your coefficients on your z equals that constant. So the first equation should be 9x plus 5y plus 9z equals -2. It looks like they all have that, except this one has a minus sign, so not that one. Okay, the second one should be 8x, and then we're going to be missing the y. There's just no y going to be there, so 8x plus 8z equals 4. So not this one because it has a y there. And so then you can narrow it down. Oh, something else is wrong. Oh, yeah. So you can narrow it down to those two and then figure out what it is, looking at the third equation. All right, write the system of linear equations represented by the augmented matrix. Use x, y, and z if necessary to write w for variables. Then use back substitution to find the solution. All right, so this equation is already written for us in row reduced form. So we are going to just use it to solve for x, y, and z. So remember, this is saying x plus 7y minus 9 equals -9z equals -2. Y minus 2, plus 2z equals -5. And z equals 3. So you have that nice triangular system, and you can use back substitution to solve. So first plug the z in here to get y, and then plug y and z into the first equation to figure out x. Now getting into some row operations. So this one is asking you to multiply row 1 by 1/5. So the other two rows shouldn't change at all. The first row gets multiplied by 1/5. So we know this is not it because I can see that the other rows are changing. That one got row 2 multiplied by 1/5, so it's definitely not it. All right, so let's check and see what row 1 should be if I multiply the whole thing by 1/5. So I'm just taking that row and multiplying by 1/5. So 15 times 1/5, -35 times 1/5, -10 times 1/5, and -50 times 1/5. So this should be your new row 1. 3, -7, -2, -10. Notice the mistake here was that they didn't multiply the constant as well. You should always multiply the constant. The constant changes along with everything else. All right, slightly more challenging row operation here. You're going to multiply row 1 times -3 and then add that to row 2. And actually, to be consistent, I should have changed this to match the notes, and I will do that for the test as well. I'll try to fix the review before y'all see it, but row 2 plus -3 row 1 is what we would actually say. So I'm taking row 2 and I'm going to add -3 of row 1 to that. All right, so how would that look? So row 1 and row 3 are not going to change. But row 2 is going to get -3 times row 1 added to it. So it's going to be -5 minus 9. -3 times row 1. 0 plus 12. 2 minus 3. Just taking row 1, multiplying it by -3, and adding that to row 2. And then -2, which is the current row 2, and then 2 times -3 gives me -6, so -6. You can do that all in your head. Go for it. If you need to write it out even more, you can do that as well. Whatever you need to do to get this correct. All right, so I'll find my answer. Okay, so row 1 and row 3 should not have changed. And then my second row, I should have -14, 12, -1, and -8. All right. Solve the system using matrices. Use Gaussian elimination with bag substitution. So you want to first set up a matrix here. 1, 1, 1, -2, 1, -1, 5, 26, 5, 1, 1, -14. And then we are going to use our row operations to get this in row echelon form. All right, so first I'm going to get zeros here and here by adding row 2 plus -1 row 1, and row 3 I need to do -5 row 1 or row 2. You could do either one. So my first row is not changing because I like that one there that it already has. This one will have a 0. I'm just subtracting row 1. So 26 minus -2 gives me 28. 0, -4, -4. If you need to use your calculator like I do on this one, we've got -14 minus 5 times row 1. It gives me -4. Lots of -4s there. All right, and then I'm going to multiply row 2 and row 3 to make both of those coefficients 1s. So I'm going to row 2 times -1/2. I want my columns there to have 1s in them, so -1/2. Row 2, -1/4. Row 3. All right, and then the last thing I need to do is make this 1 into a 0. So I'm going to add row 3 plus -1 row 2, or you could say row 3 minus row 2. So I'm doing 1 minus -2, 1 minus -14. Sorry, that wasn't the last thing I need to do. Now I need to multiply this by 1/3 to make that coefficient into a 1. So row 3 gets multiplied by 1/3 so that I have a leading 1 there as well. So 1, 1, 1, -2, 0, 1, -2, -4, 0, 0, 1, 5. So remember the goal, that first goal there that we had, and I'm really bad about not drawing these lines here. You really don't have to put them, but it does help a lot of people remember that's where the equal sign goes. But your goal there was to get 1s in that diagonal, so that now I have equations x plus y plus z equals -2, y minus 2z equals -4, and z equals 5. So you have that nice triangular system, and you can use back substitution to get your solution. So z equals 5. I will plug that back into the second equation. Y. All right, just notice that I miswrote something here. That should be negative 14. Right there, I just lost the 1. All right, so made a mistake there. So now I have y minus 2 times 5 equals negative 14. So y minus 10 equals negative 14, y equals negative 4. And then we'll plug the y and z into the first equation. So x equals negative 3. So negative 3, negative 4, 5. Negative 3, negative 4, 5. And I'll let y'all do this last one on your own. Same process. Use your row operations to get that diagonal of 1s, and then back substitution to get x, y, and z.